And here we are. When we apply composite restorations, we mentioned that we should light cure the composite. Why do we light cure composite? Because I need to transform the monomers into polymers. And one of the best ways to activate the polymerization reaction of composites is by light and sometimes by chemical activators. In the polymerization reactions, it is very important to know what does the degree of conversion means. It means the percentage of carbon to carbon double bonds, like in this video, that will be converted into single bond. And this is the actual meaning of polymerization reaction. I need the monomers that have double bond between the carbons to be activated and transform these double bonds into single bond. And when it is transformed into single bond, it will form like a chain. And this chain will give the monomers different physical properties. Monomers in their free state, they are solutions, but when they react to each other and polymerize, they will become longer, and then they will transform into solid material. And this is why we apply composites first into the cavity and do manipulation, give it the form, the anatomy. And after that, we light cure it, we activate it to transform this soft material into a hard material. Okay? Complete polymerization of composite is determined by degree of conversion of monomers into polymers. We wish to have 100% degree of conversion. Actually, this is going to be the perfect type of composite. But unfortunately, in the market now, we have composites that have conversion rates up to 77%, which means part of monomers will be free, will not enter the reaction. So these monomers are called free monomers, and they will be released into the saliva after you place your composite within the first 24 hours. Unfortunately, these materials are carcinogenic, they are toxic, so the degree of conversion when it is higher gonna be better for our health first and gonna be better for the properties of the composite restoration as well. Photoinitiators is a compound that undergoes photoreaction on absorbing the light and initiating the free radical addition polymerization of the resin monomers, which means we have special materials, special um, compounds that are used within the composite and within the adhesive system. They have the ability to be initiated, to be activated by light, and when they are activated, they will induce the free radicals to activate the other monomers and thus will start the polymerization reaction. And I think if you studied the polymerization reaction types, it is called addition polymerization. Okay? It can transform the physical energy, which is the light, into chemical energy of free radicals. What are the photoinitiators that are used in composites? The most commonly material or compound that is used is camphorquinone. Okay? This is most commonly used on composite nowadays, but we had other compounds in the past. If we make extra lecture about composite composition, we're gonna talk about them. Comfrequinone is used to dominate over all other photoinitiator because it has the ability to initiate the polymerization reaction quickly and will transform its when you apply the adhesive system, you can see that the bond is yellow in color. Actually, this color came from the comfrequinone. It is yellow solution, and when it absorbs water, it will turns into almost a translucent whiter shade of the composite, and thus will help also in determining shade of composites as well. So it is initiator and also help in determining shades of composites. What may happen if the polymerization is not perfect, is not complete? This is what we called polymerization reaction, which means after polymerization, the size of composite may become less. And when it becomes less and contracted, shrinks into the core of the composite, the result could be fracture, lower wear resistance, um, release of unreacted monomers, higher micro leakage. These spaces and gaps will be more and more micro leakage, lower adhesive bonding strength. We may lose the restoration after a few months, faster change of color because of incomplete polymerization and the presence of high amount of free monomers, post-operative sensitivity, and secondary caries. All of these are consequences of polymerization shrinkage. And clinically, I can feel that like pain in the patient, discoloration, secondary caries, and sensitivity. Sometimes cracks on the lateral walls. Light is measured by its wavelength in nanometers. We have another term that you should know about it, which is LCU irradiance, which is defined as the amount of power over the emitting light tip area. This is important because it shows me how much this device, this light cure device, is powerful and enough for me as a dentist to be sure that I'm polymerizing the composite completely. The received number of photons at the appropriate wavelength is critical to ensure adequate resin conversion. That's why nowadays comfrequinone is the most commonly used photoinitiator because it could be affected by halogen and lead light cure machines, and the number of photons that are initiated going to be high, then higher free radicals and more polymerization. Polymerization is initiated when the LCU, which is, as we said, the amount of radiant over the surface area, activate the photo initiator within the uh, polymerization reaction. The optimal photoinitiator activation occurs when its peak absorption matches the wavelength. And this is why we have to choose the proper device for light curing. And not even just choosing, we also have to calibrate our light cure devices once every few months to be sure that we receive enough power to activate the photoinitiators. This LCU irradiance, they are the key factor to induce the carbon-carbon double bonds reactions. We know that insufficient light irradiance may be responsible of several post-operative complications. We talked about them. So we have to follow the instructor and the manufacturer instructions when we choose the LighTCure device. They will be a text about this composite could be activated by 300 to 400 microwatt per centimeter square, or maybe 700 microwatt per centimeter square. It could be written in the instructions of composite and adhesive system use. So we have to follow these instructions. We have to calibrate our devices, and we have to be sure that the light is enough. There are many factors that affect the degree of conversion. I am, as a dentist, I wish to transform all monomers into polymer, but this is not the situation, unfortunately. So what are the factors that affect the conversion rate, and how can I change these factors in the clinic to achieve better results? First of all, curing time. Second, shade of composite. Distance and angle between the light and composite surface. Source and resin. What type of resin I am using. The temperature, if it is winter or summertime. Resin thickness, thickness of layer. Inhibition of air, if I'm using a glycerin to inhibit air or not. Type of filler, if it is macro, micro, or nano, or hybrid. Intensity of a curing light. All these factors affect the conversion of monomers into polymers. Let's talk about them one by one. Did I mention them at the end of the lecture? Yes, here. Yeah. Before I will talk about these factors one by one, I want to explain the 4 types of light curing systems in the market nowadays. The first one is tungsten quartz halogen. The second one is plasma arc curing unit, light emitting diode, argon laser curing unit. Tungsten carbide, tungsten quartz halogen curing light. It is a conventional light curing machine. It is the one of the oldest curing machines in dentistry. It had been used for a long time. It used a lamp of halogen that has a wavelength between 410 to 500 nanometer, but this halogen lamp has limited working time, that it has so short working time. I don't know if you remember when you were a child, even at home lamps were halogen, and once every few months your father were replacing these lamps. It is not like the situation nowadays. Nowadays we mostly use LED lights at home. So these halogen lamps, they were used for short lifetime, which is about 100 hours. But 100 hours for light curing composites, it means up to 3 to 4 years. But the problem is that halogen produce temperature, produce heat during polymerization, during working. That's why these light may hurt the patient and cause post-operative sensitivity, and also the intensity of the light with time may change during to the power of the halogen itself. Light curing by the halogen um, is time consuming because we need to polymerize for longer time to achieve the needed intensity of power. And as we said, it elevates heat, and this increase in temperature may affect the vitality of pulp and cause hypersensitivity. The other type of curing systems in dentistry is plasma arc curing unit. It had been manufactured in the late 90s, and the system is introduced because it is rapid light curing machine. So they were trying to fix the disadvantage of halogens by creating something that works quickly. The mechanism of work of this machine that it generates high voltage, high power, and this ionized the xenon gas inside the lamp into a mixture of ions, and then these ions and electrons will release the energy of plasma that will initiate the polymerization reaction by affecting the comfrey and usually comfrey is affected by light, visible light between 450 to 500 nanometer. So any light curing device that has wavelength between 450 to 500 or more can affect the comfrey and can polymerize the composites. Because plasma arc curing units produces high intensity of light, it could be used for very, very short time, which is up to 6 to 9 seconds. This is very important for the dentist actually, because as you save time, the session time gonna be shorter. You may take more patients, you will be happy, and the patient also will be happy. But is this machine really effective in curing composite? Unfortunately, it is not. It were really effective in activating bleaching agents. So it is used well for bleaching. It can activate large surfaces, but cannot be introduced and used for small cavities. Also, it is very expensive machine. That's why plasma arc are not used in the market widely. After the history of halogen and the quartz lights, the dentists started to work with light emitting diode units, which are called LED units. Why? Because LED, this light, has long lifetime. So it is different than the halogen because it has higher or longer lifetime. It emits the power that is also in the range that affects the comfrey. It is cheaper, safer, and produce less heat. That's why now it is used widely. So what are the advantages of LED? It has low power consumption. It can be used with batteries also. It does not require filter as the halogen. Long lifetime, which is about 10,000 hours. Halogen was just 100 hours. So there's a big difference between them. Minimal changes in the light output over time, but even though we need to calibrate the device once every several months, okay? The only disadvantage is that lead can only affect composites that has the comfrey. So if I have different initiators like tertiary amine, this machine, this device will not affect the polymerization. The last machine that is used also for light curing is argon laser. Do you know what is the difference between laser and light cure? And and visible light? No. Okay. Lasers has also wide range of wavelengths. And according to the intensity and the wavelength, we have different types of lasers. We have carbon dioxide, which is the highest wavelength. We have also erbium laser. We have also netium laser. We have also argon lasers. For light curing, if I am talking about something between 400 to 500 nanometer, I should use argon laser because this is the only laser that has this range of wavelength. That's why argon laser were chosen for the intensity of 200 to 300 microwatt to be used for light curing composites. But what are the advantages of this machine? Laser, as you know, it is like a beam of light. That's why the intensity of light gonna be the same, uh, even if the tip of the device is large. That's why it will help in giving a uniform polymerization. So the distance between the tip of the argon laser and the surface of composite will not affect the intensity of light. So the curing gonna be good, the depth of curing gonna be greater, the degree of conversion gonna be higher, and that's why it could be used for darker shades of composites. But unfortunately, the argon laser may affect the adjacent teeth and the adjacent restorations, and due to the regeneration of heat during polymerization, it may affect the vitality of pulp and cause sensitivity. So briefly, we have different devices for light curing. Halogen was the most commonly used in the past. Nowadays, the most commonly used is lead. We have plasma arc and we have argon laser, and both of them have limited use in dentistry. Now, how should I apply the light? If you have a lid machine, you're gonna find a button which wrote and named like mood. And if you press this button, you can change the pattern of light curing. Like you can do a uniform continuous cure. You will start and end with the same energy, with the same intensity. You can do step curing. You will start with low intensity, then you will increase the intensity by time. You can use the ramp curing, which is continuous increase in the intensity of light. You can use also high energy pulse, which is like you can start light curing with high energy, then off, high energy, off, high energy, off. So, which is the suitable mode for polymerizing composite? Usually, we start with soft cure, with ramp cure. We start with less intensive, less intensive energy and increase the intensity of energy with time. What are the other factors that affect the efficiency of light curing? First of all, the distance between the tip of the device and surface of composite. When the distance increase, the percentage or the conversion rate will decrease. Look here, at the top of the composite, it's up to 65% conversion rate. In the middle, 45%, at the bottom, 15%. So this degree of conversion were decreasing when the depth of a cure increased. So this relation means, first of all, I have to apply composites in very thin layers, which is about 1 to 1.5 millimeters thickness, because at that thickness I can achieve the best conversion rate. Then I should be light curing the composite surface from zero distance area, from zero distance, to be very near to the surface of the composite. But look at this picture. Imagine that you have composite at the bottom of this cavity, and the closest area, the closest space, the closest distance to use the tip of the light curing area is the cusp height. So you have at least here, as you see, 4 millimeter distance. In this 4 millimeter distance, the intensity of light will decrease. So if it is supposed for us to light cure composite for 20 seconds, in this situation, you have to increase the time of curing, cure for 30 seconds, and achieve better conversion rate. The other factor that you can also think about it to increase the efficiency of light curing is the direction of light. Look here. You have devices that give the light, it's gonna be with high intensity at the tip, and then will spread laterally. And when it spread laterally, it will be distributed over a huge area. Then the intensity of light gonna be less. Look at these machines, both of them spread laterally. But this machine has parallel light beams or light waves. So when they are parallel, the intensity of light will not decrease. So the energy gonna be enough to cure the composite at this surface. But imagine that I have composite here, I have composite here, the intensity of light that reach this area is less, it is less, but here it is the same. So I have to prefer a system or a device that can use filter or that can be able to transmit the light like beams over specific surface area. Again, look here, spread laterally, spread laterally. This is almost parallel. Look at the energy zone. Here, the peak, it was on this surface area, larger, larger. So I suppose that composite at this point will be polymerized better. The other tip that you should take care of, the shape of the tip. Look here at this device. This is a straight light cure. And when you use this straight light cure, you can place it directly over the tooth, even on the upper and lower teeth. But look at this picture. If you use this angulated, then to cure the lower posterior teeth and to put it perpendicular on the surface to increase the conversion rate, the tip or the part of the light cure will contact the upper teeth, and you may not be able to put it perpendicular. and it will result in this situation. Look here, if it is not perpendicular, the intensity of light gonna be directed obliquely, and these black areas will not have enough light to be polymerized. So these composites in shadow will keep unpolymerized. But this is not the situation if it is 100% perpendicular on the surface. Then all the light will be transmitted at the same time equally to all parts of the composite, and evenly it's gonna be polymerized. Okay, again, look at this picture. Here is the difference between different systems, where according to the shape of the tip and how much it's going to be difficult to use it in the patient's mouth, and how it affects the polymerization of composites. Again, I need also the tip of the LightCure machine to be in different sizes to be enough to be used for different type of restorations. Like if I am using this tip, which is small, and at the same time I use it not perpendicularly, it was obliquely, laterally applied, then look here, the light will affect part of the class 2, and this composite in the shadow will not be polymerized. But if you use this machine, which is straight with larger tip, you can see that all parts of composites were polymerized. So I need the tip sometimes to be large and sometimes to be small enough to polymerize specific points or specific small cavities. Most, look, this is very small, this is medium, and this is high. So each tip could be used for its indication. So I prefer to have a LightCure machine with different tips. Also, some machines in the market, they have special filters. Like I can have a filter that help in diagnosis of caries, a filter that can help in diagnosis of cracks. I can have a filter that help in shade selection, and I have different tips to help in polymerizing specific areas, like if I'm curing the composite under brackets, orthodontic brackets, if I'm curing um, uh, the veneers. So it could be with different tips. Also, it could be with different power, like the standard one in Valo system, which is the best system now in the market, is 1000. And if you are using it for per layer, you can use it just for 10 seconds. And for the final cure, after finishing the composite, you can use it for 20 seconds. But when you increase the power, you will decrease the time you use. So when it is 140, you will use it for 4 seconds for each layer and up to 12 seconds for the final cure. If it is extra power, like 3200, you can use it for just 3 seconds. And actually, we prefer not to use this powerful machine. Keep it to the standard level, and maybe you will need this power to initiate the bleaching reaction. So this is all about light curing machines. Thus, we at least covered one topic, which is necessary for composite restorations. And at 12, we will cover other topics, okay?